you ever entertain the idea that it's possible that we are the only intelligent life in the known universe?
I tend to restrict myself to the galaxy.
Right.
So I do think it's possible that at the moment there's one civilization in the Milky Way.
Wow.
And that's us. I'm sure there are other civilizations out there in the universe because there are 2 trillion galaxies. I just can't believe this hasn't happened in other places. The question is, how often does it happen and how widely spaced are the civilizations? And I think they're very widely spaced, and I think there may be 1 or 2 per galaxy on the average.
Are we the only inhabitants of the universe? Does intelligent life exist beyond Earth? These questions have captivated scientists for centuries. In our observable universe, there are approximately 70 sextillion stars and roughly 10 million billion planets revolving around them. The incomprehensible vastness of the cosmos surpasses human understanding. The concepts of either being solitary in the universe or it being abundant with life evoke both awe and apprehension. While some scientists, like Neil deGrasse Tyson, speculate that there might be hundreds of civilizations in the Milky Way Galaxy alone, Brian Cox, the renowned physicist, suggests the possibility of no intelligent life in the universe. Moreover, even if it exists, he argues that we will never detect or communicate with it. Why does Brian Cox hold this belief? What leads him to suggest that communicating with extraterrestrial life is an insurmountable challenge? And how extensive is the universe? Join us as we delve into the vastness of our universe and explore why Brian Cox believes that we are the only civilization. When we gaze at the vast starry expanse of the night sky, we recognize our own insignificance in the grand scheme. The countless twinkling stars above affirm that our humble abode, Earth, is merely a tiny fragment in what we commonly call the universe. A quick glance at the celestial dome is enough to understand that the universe must surpass our wildest imaginings in size. But can we fully grasp the vastness of the universe through scientific means? This question remains a central focus in cosmological research. It's possible that this question may forever escape a completely satisfying answer. However, this doesn't stop experts from working to unravel it. Currently, we know that the universe, as we understand it today, came into existence approximately 13.8 billion years ago. The Big Bang, a process outlining the emergence of matter, space, and time from a previous singularity, is considered the cosmic genesis of our universe. In physical cosmology, the cosmic microwave background radiation plays a crucial role in exploring the earliest state of the universe. This radiation, existing in the microwave range, originated during the Big Bang and continues to traverse the vast expanses of the galaxy today. Through various measurements examining this radiation and correlating it with different distances, researchers have estimated the age of our universe. This implies that we can currently peer 13.8 billion light-years into space from Earth. To illustrate, picture a spherical drawing with Earth at the center. The rest of the sphere represents the observable region from our blue home planet. In technical terms, the universe within our sight is termed the event horizon. Specifically, the event horizon encompasses objects whose reflected light is barely visible from Earth. Nevertheless, processes occurring beyond this event horizon remain entirely invisible to our human eyes. As we are uncertain about what lies behind the observable universe, determining the overall size of the universe becomes a particularly challenging task. Consider the vastness of the universe. If we ponder the sheer magnitude of the entire cosmos, a crucial fact emerges. Contemporary experts affirm that the universe is in a constant state of expansion. Back at the time of the Big Bang, an object was approximately 13.8 billion light-years distant from Earth. However, owing to the ongoing expansion of space, the separation between this celestial body and our home planet has now extended to 46 billion light-years. This circumstance implies that in the future, objects in the sky not visible to us today will become apparent. Simultaneously, certain celestial bodies will vanish from our star charts due to the universe's expansion. Naturally, during these observations, we place Earth at the center. This choice is dictated by spatial constraints, as we have no alternative but to designate our home planet as the central reference point in our star charts. However, determining the specific location of our blue home planet within the ever-expanding universe remains an unanswerable question. The exploration of the universe. As previously mentioned, international teams of experts consistently work to understand the vast dimensions of space. Despite facing various challenges, researchers employ diverse methods to investigate the immense expanse of the universe. Key research techniques involve specific measurements focused on the radiation of the early universe. Through these radiation patterns, scientists can determine various distances and attempt to measure the dimensions of the universe. The oldest light source identified by researchers is located 92 billion light-years away from Earth. However, this doesn't necessarily mean it marks the outermost limit of the universe. Deciding whether the universe has an endpoint is a more complex puzzle than one might initially think. Essentially, the farther an object is from our home planet, the longer it takes for the light it reflects to reach Earth. Some galaxy objects are so distant that the light rays they emit require billions of years before becoming visible from Earth. Considering this, numerous light rays are still traversing the universe toward us, journeying for billions of years, but yet to arrive. The universe's shape remains an unanswered research question, crucial for sizing up an object. The true configuration of our universe remains elusive. While some scientists propose a self-contained sphere structure, possibly part of a larger multiverse, others argue for a flat, potentially infinite space. Following the first idea, our universe would be a self-contained structure with an eventual endpoint. If our galaxy has limits, there might be a chance to calculate the universe's dimensions with the right data. However, if the universe is infinite, figuring out its size becomes a tricky task, as infinite things lack specific boundary points for mathematical definition. According to NASA, the universe is a flat construct of boundless proportions. Still, our universe is not forever. It has a finite age and started around 13.8 billion years ago. That's why our exploration is confined to the time between the Big Bang and today, a question without a definite answer. Despite international teams of experts not having a clear understanding of the universe's true size, they confidently say it's an incredibly vast, potentially endless structure exceeding all our horizons with its immense dimensions. Investigating the universe precisely is a task spanning many generations of experts. Even if we might never fully grasp the detailed enormity of the universe in our lifetime, this fact doesn't lessen our fascination with the intriguing world of distant stars and planets. Brian Cox recently expressed skepticism about the likelihood of human contact with intelligent extraterrestrial civilizations. He voiced concerns that scientific and engineering progress could outpace political development, potentially leading to disasters. He suggested that advanced extraterrestrial life might have unintentionally caused its own extinction due to this imbalance. Cox's perspective aligns with the Fermi paradox. Despite the high likelihood of extraterrestrial life, there's a lack of evidence or contact with such civilizations. He suggests that a civilization's potential for self-destruction could hinder its ability to communicate with other star systems. In his view, technologically advanced civilizations capable of self-destruction need global collaborative solutions to prevent disasters. He stresses the importance of political leaders adopting an evidence-based approach rather than relying solely on ideology. While Brian Cox leans towards the idea of intelligent civilizations facing self-inflicted challenges, he remains open to the possibility of discovering non-intelligent extraterrestrial life forms. Considering the potential discovery of microbial life in ocean worlds within and beyond our solar system, he acknowledges that the search for extraterrestrial life may yield interesting results. Now let's delve into some hypotheses explaining why we might be the sole civilization, or why communication with intelligent life beyond Earth might be unattainable. The rare Earth hypothesis suggests that Earth's unique conditions, including a stable star, suitable atmosphere, and planetary interactions, may be exceptionally rare, leading to the emergence of complex life. Factors like a large moon and gas giant planets play crucial roles in creating a habitable environment, showcasing Earth's fortuitous cosmic luck. Additionally, plate tectonics, as highlighted in the hypothesis, play a role in Earth's long-term habitability by regulating climate and recycling essential elements. The occurrence of fortunate events, such as the evolution of eukaryotic cells, illustrates the intricate environmental factors and evolutionary contingencies that have shaped life on our planet. The Great Filter hypothesis presents significant obstacles in the abiogenesis process, suggesting that specific stages, from non-living matter to intelligent civilizations, act as filters, diminishing the likelihood of advanced life. The transition from simple to complex life forms and subsequent stages encounter potential filters, including catastrophic events and challenges in developing intelligent, technologically advanced species. Earth's advanced civilization might be an exception in a universe where these filters restrict the emergence of widespread extraterrestrial civilizations. The galactic quarantine hypothesis proposes that advanced civilizations deliberately refrain from interacting with emerging societies, implementing a form of self-imposed isolation to avoid unintended consequences. Concerns about sharing advanced knowledge or technology and anticipating potential risks and socio-cultural challenges lead these civilizations to uphold a cosmic quarantine, respecting the natural evolution of less advanced cultures. What's your take on this topic? Do you think extraterrestrial civilizations exist somewhere in the universe? Share your thoughts in the comments.